everyone, I am Thamilsaran from AD's department. Today we are going to talk about the Multilayer Perceptron MLP on Non-Linear Separable Data XOR problem. We are going to talk about the objective, implementation of the program and the application. Objective. The main objective of the experiment is implement the Multilayer Perceptron using the Python to solve the non-linear separable data set, specifically the XOR problem. In machine learning, some problem cannot be solved using the single layer perceptron because they requires model to learn complex pattern. The XOR problem is a classic example of such a case. To overcome this limitation, we use the multi-layer perceptron, which is hidden layer which enables the neural network to learn the non-linear relationship. In this experiment, the network is trained using the forward propagation and the backward propagation, and the model learns by adjusting the synaptic weights to minimize the loss. The final goal is correctly predict the output of the different input combination. Next, we move on to the implementation. Firstly, we need to import the needed libraries. We imported pandas, IO and matplot. Pandas are handling the dataset IO used for input and output operation. Then matplot.pyplot is used to plot the graph. Next, we defining the input and the output. This represent the XOR problem, which is non-linearly separable. Then we are defining the network parameters. These lines defines the structure of the neural network. Nx number of input neuron, Nh number of hidden neuron, Ny is the number of output neuron, M is the number of training example, Lr is the learning rate used to update the weight during training. Then we are initializing the random weights. Random weights are generated for the neural networks. W1 is the weight between the input layer and the output hidden layer. W2 is the weight between the hidden layer and the output layer. Loss is assigned as an array list used to store the loss values during training. Next, we use the sigmoid activation function. This function implements that converts the values between zeros and 1, useful for binary classification problem. The formula is sigmoid equal to 1 by 1 plus exponential of e exponential power minus 1. Next, we are using the function forward propagation. In this function, Z1 multiplies the values with the hidden layer weights, and A1 is applies the sigmoid activation function, repeatedly doing for the second neuron also, Z2 return the values, applying the sigmoid again for the final output. Then we are doing the backward propagation function. Backward propagation calculate the errors and the gradients. dz2 is calculate the output error. dw1 calculate the gradient for hidden layer weight. Next, we reshaping the W1 and the dw1 dw2, returning the output. Training the neural network using the iterations approaches. Each iteration perform the forward propagation, loss calculation, backward propagation, weight update. Then after calculating the losses, we going to plot the graph, loss graph. In this graph, we visualizing that loss decreases from 0.70 to the 0.41, indicate the successful learning. Next, predicting function. This function is used to predict the output for new inputs that perform forward propagation and checks that if A2 is greater than or equal to 0.5, output classifies as 1 and or classifies as 0. Next, testing the model. The trained model is tested using the different combination of the inputs, and we got the same correctly matches the XOR truth table as we achieved the XOR problem. Then we talk about the applications. Multilayer perceptron widely used in many real-world applications because they can learn complex and non-linear pattern data. One important application is image recognition. When MLP model are used to identify the object, handwritten digit and face is the image. Another application is speech recognition, where neural network helps to convert the spoken language into a text voice assistant and the speech processing system. MLP are used in medical diagnosis, where